Welcome to everyone. I am Mr. K.S.Rangasamy, Department of Electronics Engineering from K.S.Rangasamy College of Technology, Trichangood. Today I am going to present a lecture on placement, which is a very important stage in VLSI physical design. The placement determines where each standard cells or logic element is located on the chip and strongly affects the performance, power and routability. So in this lecture we will first explain what placement, then introduce the key challenges involved in placement, and finally discuss the major stages such as global placement, detailed placement and legalizations. What is placement? The placement is performed after partitioning and floor planning. Once the chip area is blocked, outlines are fixed. The placement decides the exact location of standard cell within each block. The main objective of placement is to minimize the total wire length while satisfying the design constraints like timing, congestion and then powers. So the placement happens before routing. So during the placement, the standard cells are partitioned inside predefined rows. The good placement improves the routing quality and reduces the delay and lower power consumptions. The poor placement can lead to routing congestions and timing violations even if the logic design is correct. So in this picture, we will show the linear placement, which consists of only one row, and then a two-dimensional placement, which consists of a two number of rows, and also the placement and the routing with having some kind of standard cells. Next one is the challenges in placement. So there are several challenges in placement. The first, handling the very large netlist with millions of cells is complex. And second, the overlap between cells must be avoided. And third one, there is a trade-off between timing optimization and wire length minimizations. Finally, handling the large macros along with small standard cells make placement more difficult. And next one is a global placement. The global placement focusing on finding approximate location for cells. It usually ignores the exact shape and grid alignment. The sum of the overlaps are allowed at this stage because the goal is to achieve good overall wire length and density distributions. The legalization is required later to remove all the overlaps. So this global placement, which is mainly used for the rough but fast optimizations. And next one is a detailed placement. The detailed placement refines the result of global placement. It uses the local operation such as swapping cells or shifting cells within a row. The objective is to improve wire length, timing and congestion while keeping cells close to their global placement positions. The detailed placement offers the fine control over individual cell locations. And next one is the legalizations. The legalization ensures that all the cells are placed on the valid rows without overlap and satisfy the design rule check. It is often performed before or during the detailed placement. The goal is to make the placement physically valid while minimizing the impact on performance. To summarize this lecture, the global placement gives a rough solution, the legalization make it valid, and detailed placement, the fine tunes the solutions. All three stages works together to achieve an optimized manufacturable layout. So the good placement improves the chip performance and reduces the routing complexity and enhancing the manufacturability. I hope all of you understand this topic. Thank you for your attention.